So in this question, there are two small spheres of same mass and they are attached at the two ends of a light rod of length L as shown here. The whole arrangement is placed on a frictionless horizontal surface, and a third sphere of same mass moving with velocity v0 on the surface strikes with one of the spheres elastically and rebounds along its original line of motion. Find the angular velocity of the rod after the collision. So these are the two spheres. They are connected to a light rod, and a third sphere of same mass is coming with velocity v0 and it's striking with one of the spheres, and it is returning in the same line, and the collision is elastic, and we have to find the angular velocity of the rod after the collision. Okay, so this is the situation before collision as it is given in the question, and after collision, suppose this ball is moving, this sphere is moving back with velocity u, and suppose this arrangement, I've taken this arrangement as system A. Suppose the center mass of system A is moving with velocity v, and the rotation about center mass of this system is omega. Okay, what we can do, since it is placed on a horizontal surface, all weights will be cancelled by the normal reaction of the horizontal surface. So there is no external force acting on the system. All external forces cancel out. So what we can do, we can apply conservation of linear momentum. So taking this direction as plus. So what is momentum before collision? So before collision, momentum is m into v0 in positive direction. So it is m v0 in positive direction. After collision, it is m into u in negative direction. So it is minus m into u, and there is momentum in this system, and since the system is combination of many bodies, we can write momentum of our system as equal to the mass of center mass into velocity of center mass, that is 2m into velocity of its center mass that we have assumed as v. So this is conservation of linear momentum. Now we have to apply conservation of angular momentum, because there is no torque acting on the system. So suppose we choose a point P in this line somewhere here, then before and after collision, this sphere will have zero angular momentum because its velocity is in the line of P. So this will have angular momentum initially and finally 0. So now we have to write angular momentum of this A, system A. So that we can write as angular momentum of center mass plus angular momentum with respect to center mass in two parts. So what is angular momentum of center mass? So center mass is a particle of mass 2m and its velocity is v, and its perpendicular distance from P is equal to L by 2 root 2, that you can check. This is L by 2, this is 45, so this distance is L by 2 cos 45. So angular momentum of center mass is 2m v L by 2 root 2, plus there is another part which is angular momentum with respect to center mass. So this is I omega. I of this system A is about center mass is m into L by 2 square, and since there are two masses, so this is I into omega, and this will come with a negative sign because with respect to P, this velocity, the direction of this velocity v, will make an angular momentum in clockwise direction, while this omega is in anti-clockwise direction. So they are in opposite directions. So one will have plus sign, the other will have minus sign. Coefficient of restitution for elastic collision, it is 1. So it is equal to velocity of separation over approach. So what is velocity of approach? So this is line of impact along which we have to write E equation. So along this line, the approach velocity was v0, so that will come downstairs, and after collision, this ball will go back with velocity u, and due to these two velocities v and omega, this ball will have a resultant velocity v and L by 2 omega. So these are the two velocities in this sphere due to translation and rotation. So the component of this velocity along this direction will be L by 2 omega by root 2. So velocity of separation is this u plus v. This v is also separating the two bodies, and plus this. So, and this is all equal to 1. So now we have these three equations which we need to solve, these three equations, and we can solve for omega. So that remains to be done, and which is purely a mathematical part of this question which you can do easily. So solve these three equations and you'll get omega equal to this. Okay.